Let me check. I think we are live now. So first, apologize. And this is why we had nobody in the chat. We were starting, but we were not streaming yet. So if people can confirm in the chat on Twitch or LinkedIn or YouTube that it works, because it seems that this time maybe I didn't push the button strong enough. And we are now live. I'm checking that we should be there. So just restarting, saying hello to everybody. We have started 2 minutes before, but we were not live. So hello to everybody. Welcome to any discussion, comment, question, or simply saying hi in the chat. And I was mentioning that this week there is the biggest Postgres conference, that is the European Postgres conference in Athens, and we were talking about the latest blog post from Brett. So maybe you can just start again. I will share my screen to show it.
Yeah.
I find it.
So I wrote on the Dino 2.0 release. Dino is a competing runtime to Node.js. So this is in the JavaScript ecosystem for those of you building microservices potentially in JavaScript. So Dino is developed by the original creator of Node.js to sort of right what he sees as some of the wrongs in his architecture of Node and some of the security lapses in that development. So this is a pretty big release in that it's backwards compatible with Node. You can use npm packages where previously you were not able to do so. So I think a lot of enterprise players using Node.js might potentially be moving over to Dino, given that it's more performant, but also compatible with older repositories and older projects now. So it's worth at least looking into for 30 seconds if you want to check it out.
So you say backward compatible means that you can switch to Dino and not change anything in the application and then use more feature from it.
Yeah, instead of running your project with Node, you can run with Dino and everything will work. You can import packages from npm. You can set security such as being able to read and write from the file system, being able to communicate with the internet and so forth at a more granular level. Many things that are fairly obvious, but you are also getting greater performance with underlying functionality that is in C++. In Node.js is being written in Rust on the Dino side. So there's some performance benefits there as well.
Okay,
So
cool.
pretty cool.
So about the topic that we have picked today, and of course, if you have any questions about anything else, the goal of the open hours is also to answer questions or get feedback or maybe get ideas for the next sessions. But if there are no questions, our idea was to talk about connection pooling. That's something that is used in all databases just because usually the applications need more connections than one database can handle. And they need many connections, but maybe some are idle or some may be queued. And then we need some logical connections in the application and physical connection in the database. The basic idea is that if the application has 1,000 of threads and want to run that on a database that has, say, 8 vCPUs, then at some point there will be a problem, too many resources on the database, for example. So first, I think the best is that Brett, you start talking and showing what exists for connection pooling from an application on a Postgres database.
Sure. Sounds good. Yeah, so why don't I share my screen? Let's see.
And after that, we will talk about what we did in Yugabyte and why we did it a bit differently and why we also were able to do it a bit differently. Because in Postgres, one connection is a process. Cannot change that in Postgres. You can put some proxies in front of it, but they cannot interact directly with the what happens in the database. In Yugabyte, because we use a fork of Postgres, we have more possibility to know exactly what the sessions are doing and optimize those connection pools.
Mm-hmm. So are you able to see my browser right now with the smart drivers? Yeah, so I first wanted to touch on the fact that as application developers, we're very much familiar with using client drivers and establishing connection pools in our backend applications. Yugabyte being a distributed Postgres database has some additional considerations. Our driver can be cluster topology aware, so your driver will have logic essentially for connecting to various nodes across a cluster. And this is configurable using the Yugabyte smart drivers. So these are available in a lot of very prominent languages here and have certain features that are important in a distributed database: cluster awareness, connection pooling, and so forth. So the Node.js one, since we were just talking about the Node ecosystem, is built directly on top of the Node Postgres driver, which is the most popular one in the ecosystem. So we are just adding Yugabyte specific features on top of those drivers. To move on with my demonstration, I have a Postgres database running in Docker on my machine, as well as an instance of PgBouncer, which is going to manage our connection pool. So rather than running a connection pool through a smart driver on my application instance, we can imagine in a microservices application, we could have dozens of application services that need to connect to a database. So in order to have a pooled connection on each one of these services, we could run up against connection limits on our database. Let's say that we had, 24 application services, each with 5 minimum connections in a pool to our database. We're already over the 100 connection limit, if that is your connection limit in your Postgres instance. So
the connection limit is a parameter that we set just to be sure that something bad happening will not just create thousands of processes and try to use thousands of vCPUs that are not there and allocating memory other what existing and then having the session killed by the memory ON killer.
So just to show a little bit for those who are unfamiliar with PgBouncer, there is some level of configuration being done here. You're essentially setting a proxy. You're setting a box between your application and the database, one that sits very near to the database for latency reasons. And you're setting the connection to the database, and you're able to configure various parameters as well. So, for instance, instead of connecting to Postgres directly on port 5432, you're connecting on 6432. You're able to set the maximum number of connections, the pooling mode. Here I've set it to transaction mode, which means that transactions are run and then the connection is returned to the pool upon every transaction completing. You can also run this in session mode or even statement mode, where each statement is run individually. And then you can set various things like the minimum pool size. So PgBouncer here will be by default setting a minimum of 20 connections in the pool to be used by applications connecting through it, and logging parameters and so forth. So this is some of the configurability of PgBouncer.
I may mention something about the connection modes. The problem is that SQL lets you do a lot of things that can be within a statement or within a long transaction or within a session where you have multiple transactions. There is no clear boundary. There are some SQL features that have one scope or the other. And because most of the legacy databases had dedicated connections, most of those databases started with client server, where each user was a physical connection to the database, and then nothing was really made in those databases to really have clear boundaries between the scope of something that you set. And for example, if you set a parameter in Postgres, you can set it for a statement if you have PG in plan, or you can set it for a transaction if you set local, or you can set it for sessions, and then you have a state. But today, most applications went to not have a state between multiple calls and have just small calls without relying on a state. And that's why today we need to do it differently. We cannot really dedicate one connection from the application to from one application thread to the database.
Absolutely not. So I'm going to show a demo using PgBench, connecting both through PgBouncer, so using PgBouncer as our connection pooler, or connecting directly to the database. So here I have 3 terminal windows open. One is connected to the PgBouncer admin database, one connected to Postgres, and one is just local to my machine here. So we can show the max connections on our Postgres database. I guess 100 is the default, Frank. And I can run this to show we have one connection using PgBouncer here. And we can see that we have 20 connections here through PgBouncer to our database. We are able to run this bench. First, I'm going to show this. We have 20 idle connections to our database.
And let me just interrupt you just to say hi to Crunch, to Jai, and in the chat, Nagenda is asking the best way to handle idle session in Postgres and YugabyteDB. And that's exactly what you are showing, because I see that you display the idle sessions. And yeah, that's the goal of the connection pool. Be more efficient with idle sessions.
Yep, exactly. So here, I have 750 connections. I'm going to drop this down to 75. And here I'm going to run through the PgBouncer, and I am going to run this with the uppercase C flag, which is going to mean that each time a transaction is run, the connection is dropped and a connection needs to be reestablished with PgBouncer.
So you are simulating something that is really bad design, but I've seen it in databases. For example, I've seen it with developers who used MySQL. And in MySQL, establishing a connection is quite light because it is threaded. And then they do the same with Oracle or Postgres or Yugabyte, and then they will feel this cost of establishing connections each time they have a statement to run.
Yeah, Yeah, the transactions per second are significantly lower when running with this flag, as we would expect, because if we're running the benchmark or if we're running any code while using the connection pool optimally, we'll be passing back the connection to the pool and reestablishing a connection from that pool, rather than having to establish a connection back to PgBouncer on every transaction that we're running here. So we're able to see that we have 75 connections here, and we now have greater transactions per second with lower latency by connecting directly through PgBouncer. This is actually fairly low. I've seen some variability, Frank, in running PgBench with the database and PgBouncer running locally. Like typically, this is up over 600 transactions per second, which is a significant improvement over
If I'm
running.
not wrong, PgBouncer is not threaded.
Mhm.
So maybe at some point PgBouncer is overloaded and it's possible to run multiple versions of it. I didn't look at the detail, but I know that the connection manager that we will discuss in YugabyteDB later, we based it on Odyssey more than
Yep.
others because it was threaded.
Yep. And like I mentioned previously, like every benchmark, as we all know, needs to be taken with a grain of salt. Like based on the configurability of all of these tools, we could see drastically different numbers. So the raw transactions per second, this and that, are totally relative to the setup, the number of cores, all of these things. So I'm merely showing these benchmarks as a way of comparing
Yep.
using a connection pooler or connecting directly to the database. By running this benchmark in connection establishment mode, I will call it, directly to the database, we see here that we have too many clients already connected to the database. We're seeing errors.
Mhm.
So what we're seeing here is that we have a bunch of idle connections already from running the benchmark previously with PgBouncer. Because we have a connection limit set up in PgBouncer of, I think it was 100, which is the maximum number of connections in the Postgres database. By trying to run this with 75 connections, we're over the established limit. So in order to do that, I need to run reconnect here in the admin UI. And then we're able to see that we are now establishing the 20 connection minimum automatically through PgBouncer's pool. But we've dropped all of those idle connections that are towards the upper end of our connection
Okay.
limit.
Many
So that was,
connection pools have different parameters, but usually you have a minimum that are
yep.
established at the beginning,
I
even
set
if there is no activity.
20 was the minimum and 100 was the maximum that
Yeah.
I'd set.
And I
So
guess
what?
there is an idle timeout where the idle ones above the minimum
Yep.
can be
Will
reclaimed,
get
but
dropped.
after a while, yeah.
But basically, what I just wanted to show was that without using some internal or external pooling mechanism, we can run into issues where we're trying to establish too many connections directly to the database, which is
Mm.
exactly what we're trying to avoid. So in order to run this benchmark, I can reconnect and drop those idle connections that were established through using PgBouncer. So now when I run this benchmark, this is running as we expect. We still have the 20 idle connections in waiting if we were to run through PgBouncer right now, but all of the other ones that are active or idle in transaction are actually through this other benchmark, and we can see the transactions per second here are significantly lower and somewhat similar to what we saw when running through PgBouncer while reestablishing connections. One thing I wanted to ask you, Franck, is what are these 5 connections here that are just in waiting, that are seemingly like internal to the database or something? Do
With
you
no
know?
state, if we query pgstat activity, we will have the default, but there are some background processes which
Mhm,
may not have the state. For example, the checkpointer is there, the log writer. They
mhm.
have some internal connections, but they are not really doing transactions.
So do they
So I
count?
think
Do they count as part of the total connection limit on the database then? Uh,
they count. I'm not
mhm.
100% sure, but
Yeah,
I
I was just
think
I was
they
just
count.
curious because
Yeah.
when you're filtering by state or something and you see just a blank state, I was just a little bit curious
Yeah, the
about.
states are basically active means that it is processing a statement. Idle in transaction, it's not something I would expect in modern application because that means that the application has started a transaction and then have several round trips and then commits. So idle in the transaction is idle, but cannot be reused because it is within a transaction where it has to be committed or not. And idle alone without in transaction is in between transactions. So you have committed something. And also because there is network round trip, even if you have a lot of connections, you will always see some idle one because there is the network time in between.
Hmm.
From a database point of view, it is idle because it's waiting for the next the next client.
Hmm. So yeah, this is very configurable. I have another demo that is fairly similar. I don't even know if I need to run through it where I'm comparing. We might as well do it.
Yeah,
Why not, right?
yeah.
Community Open Hours, PgBouncer test. And then I just wrote a little program, a node program here that is essentially running just a simple benchmark. I'm just selecting one um, from the database, either through PgBouncer or directly to the database. We could imagine all the different scenarios you could run, running your own benchmark. Of course, when you initialize PgBench, the Postgres, native benchmarking tool, um, various tables are created that have relations between them. But using a tool like this, it's very easy to just write your own benchmark within Node.js or the language of your choosing.
And you know exactly what you test. When you do select
Exactly.
one, you run the shortest possible query and just measure the round trip to the database. Yeah.
Exactly. So here I'm running the same benchmark, both directly on the database and through PgBouncer, and we are able to see that the transactions per second are nearly double while using the connection pool, and that is exactly what we would expect because we do not need to manage each of those connections. None of that overhead is being found. I'm actually kind of kicking myself for those of you that want to, kind of get your hands dirty with Yugabyte, learn a little bit about the different configurations of the database, the different deployment options. I wrote an application that can be spun up inside of YugabyteDB Aeon, the cloud offering
Mhm.
that um, it was the Discovery Lab, the Labs project that is a tab within the UI. And I actually wish that I'd used something like PgBouncer in conjunction with our smart driver in order to better manage the pool. I guess some of the questions that I have about these different modes in PgBouncer would be, setting certain session parameters and the stickiness of those things when I need to, for instance, set follower reads in YugabyteDB or something like that. Those are the things that I haven't worked through. I'm assuming that using Odyssey or PgBouncer, things like this could be done, setting session parameters and not needing to rewarm connections so that latency remains low without that connection overhead that then can slow you down in a distributed database setup. But those are some things that I would like to look into, and I encourage people to check out the labs application if you want to see the latency differences with different distributed configurations. Pretty cool project.
Yeah, that's a good point. It really depends on the configuration. That's why also why there is no one solution or one configuration that fits everything. Just out of my head, it depends how many application servers you have. Because with microservices, and we were discussing that before the live, in microservices, you usually have a lot of application servers, and they have maybe their connection pool, uh, and they cannot allocate too many connections because then it multiplies.
Exactly. So in this and the project is open sourced and able to be viewed under our Yugabyte DB samples project on GitHub. But there are various microservices distributed in regions across the world that are near the database instances, which massively reduces latency. But there are some configurations, some session parameters that are being set on connection to the database that enable extremely low latency reads and writes. So those are the things that I'm not sure how they work in a shared connection pooler like we're seeing here with PgBouncer, but I would like to look into that further the next time that I run or write an application rather. But that's all I have in terms of showing, the
Good.
application side of things. Now we can get a lot more lower level with you going into the built-in capability that we have now in Yugabyte. So I'm excited to learn more about that from you.
Yeah, and also we can explain, and I will share my screen. We can explain basically how we came with a connection pooler within the database. The idea, one first idea is that we need to make configuration easy. The conception of a database, when I started in databases, all companies had a team of DBAs and can build complex configuration for the deployment. Today, enterprises have too many components and it must just work without thinking too much about the configuration. So adding a proxy with specific parameters and also thinking about the mode. Is the application okay with a transaction mode or session mode and all that? That's a lot of complexity. So one first thing was to do something simple. And this is the initial Git issue, so from a few years ago, where we started to discuss what can we do for large and frequent number of connections. And that those are really the 2 points. As you have explained, there is the case where you have connections that are set up with a fixed number from the application, but most of them are idle, which means that they use a process, they use memory, and potentially they may become all active at the same time, and then they will saturate the CPU. So that's the case with the maximum number of connections. Of course, we can limit that with the max connection parameter, but then application will just get errors, which is not very good. And the other thing is the frequent number of connection, and this is what you have what you did with the dash uppercase C of PgBouncer, those applications that always reconnect. And there, I can mention that, of course, it's an anti-pattern to reconnect always, but as we said, if you have many application server, because it's microservices,
Exactly.
they
Or
must
someone's
have a
using,
dynamic connection pool. Yeah.
like, we talk often about microservices connecting from multiple instances, but think about nowadays with people running edge functions and all of the cloud functions that are being run that might just run a single transaction or something and then close a connection immediately.
Yeah.
This has become increasingly important just in the last several years.
Yeah, that's right. In a Lambda, you will not have a persistent connection pool in a Lambda. Yeah,
No.
that's right. Yeah. So those were the ideas, and then just showing that we looked at what was existing: PG pool, PgBouncer, and finally, I just have a drawing. So finally, we studied what we can do with that, and the idea was to take an existing connection pooler that works as a proxy, just because we don't want to reinvent code that already exists. The same as we did for the query layer, we just use Postgres and improve it for the distributed database. Take one that exists and put it within the database, and there are two big advantages of putting it within the database. First, we can make it transparent, not having an additional component, but also making it transparent because if it's within the database and we control the code because it's a fork of Postgres and it's a fork of the connection pooler, and then we can detect what the application is doing. So we don't need to ask the developers to configure a transaction mode or a session mode or a statement mode because we can detect what they do. Are they setting some state, some parameters, for example, that where the scope is larger than a transaction? And then we can put some stickiness to be sure that we don't reuse the connection between two transactions. Or we just detect that they are just running, like many applications, just running statements without using the session state, and then we can reuse the same physical connection for multiple transactions. So that was the idea of putting it within the database. And we used Odyssey for various reasons. I think one was the language in C, and another one was that it is threaded because we built a distributed database. Everything must be scalable, and at some point you don't want a component where all connections are going through that you have to scale differently. Just using multiple threads makes sense. Another thing that we were able to do, putting it within the database, is that we can use shared memory. For example, there are some session state, like setting parameters. We don't want to make each physical connection dedicated just because you have set application name or whatever parameter. And it's not a lot of information, so we can store this information in shared memory. And then when a logical connection is assigned to a physical connection, it can read the parameters that are mapped to the logical connection, even if it was set in a different physical connection. So those are things that you cannot do with a proxy. A proxy cannot look at the shared memory of Postgres. And especially when we are distributed, we want also a connection pooler on all nodes, because all nodes are active. We can connect to all nodes. So that was the theory. I don't know if you have some more comments, but I have also a demo for that. With the same idea, with PgBench and running. So let me show first what I have started. I have two, Docker PS. No, that's not the right one. Yeah, I have a few containers running because I'm doing a lot of things in my labs. But basically, I have one where I have set the connection manager on, and one where I didn't. And here I'm just running a client Postgres just to use PSQL and PgBench, and I link it to the one with the connection manager on. I will show the parameters for that, but we can see it with some additional parameters that we have. So we have two parameters coming with the connection manager that are like Postgres parameter, but added to Yugabyte, that we cannot change because you don't choose that when you connect, you just use what is set, but that we can query to know if our connection is dedicated, means not using connection manager, or it is a logical connection that can share different another physical connection. So this is how, when you are connected, you can know if you are going through the connection manager or not. One thing that we wanted to do from the design of it was to make it transparent. We don't want to add another port to connect so that the application has to think, oh, should I connect to the dedicated one or to the shared one? The idea is really to make it transparent, that everything works and will just work better if it's possible to share the session. But if it's not possible, they will be marked as sticky. And that's the other parameter that will count the stickiness. Basically, if you do something that cannot be shared with another logical connection, it will increase the stickiness. And then your connection can be shared only if the stickiness is 0. For example, if I create a temporary table, and if I query that, I can see that stickiness has increased. So even if I'm using the connection manager, and even if I'm idle there, my connection cannot be used by someone else, because this someone else will see my temporary table, and that makes no sense. If I drop this temporary table, stickiness is at 0, and then my connection can be back to being shared. So that's the idea of the transparency. If we can share it, we share it. If we cannot, we just cannot. Looking if we have questions before I demo with PgBench. Oh, that's a question that we have a lot. And the answer is clear. It depends. The question is, any formula do you recommend to maintain active sessions with respect to the number of vCPUs? Let us come back after that, because there is no clear answer. Basically, it depends how your sessions are active. Not all sessions are always active in CPU, but that's a very good question, and I will give my point of view on that. And Brett, you will also. So basically, what I wanted to show there to run on both, and I'm running the same query as yours that looks at the number of sessions from PgBench. For the moment, I'm running nothing, so of course we have no active sessions there. And I will create the PgBench tables, running the same thing on the two databases. In both of them, I have only one active session because the PgBench initialization, the one that loads data, is single-threaded. I think there is a project to do it multi-threaded in Postgres 18 or something, but not yet there. So if you have only one connection, then there is no difference if the connection is dedicated or not. But if I run for the PgBench, first I will show you what the default PgBench is running. So the default PgBench is TCP-like. I will run the simple update, and we can show the script of it, what PgBench is running. So it's setting some random values to run, and it's really doing a transaction where it sends a begin, and then a select, and then an insert, and then at the end it commits. So typically, I expect to see idle transaction between two of those calls, but also idle in transaction when it is in between. So that's really what a very chatty application can do. And then let's run that and see what we have on both. So on top, with the connection manager, and in the bottom without the connection manager. So without the connection manager, same behavior as Postgres without a proxy, without a connection manager. I see 30 connections because I've run explicitly, where is my command there? I've run explicitly 30 clients. So I have 30 dedicated process for them without a connection manager. And why are they idle? Because I reduced the throughput to 100 transactions per second. So to be sure that I'm simulating something where I have many sessions, but idle most of the time. So basically, I'm using here, without the connection pool, I'm using 30 processes, allocating memory for processes that have nothing to do most of the time. And the same workload here is only one active session and then only one used in the pool because it is mostly idle. So for this workload, I save a lot in memory because I do not have to allocate all of that. And something also, I've run that with the simple protocol. So the simple protocol is just sending the queries. If I show the script again, where was that? Built-in show scripts. So basically, PgBench generates some randoms number and put them in the query and then send the query with the values. It's better to run with prepared statements so that it doesn't have to parse it each time. And the big thing with prepared statements is that a prepared statement have a state in the session, because the idea is that in a session, you prepare the statement once, and then you call it with execute with different parameters. So it has a state. And this is why with PgBouncer, only the latest version, I think a few months ago, PgBouncer was able to do transaction mode with prepared statements. And it has to do a trick renaming them because to keep a state. And because it is a proxy, it has to parse the statement and then name the prepared statement. Because we are within the database, we can do it differently. We can share it in shared memory. And that's how it works. And we can see that the connection pooler is still able to reuse the connections, only one used for my workload without any active. And the throughput is mostly the same. The latency is mostly the same. There is no overhead running that. So it works with prepared statement. We can even see them if I select star from PG prepared statements. Or maybe I will not see them because I don't have a lot of connections. I will run it without the rate limiting. So without the minus R that limits the rate to 100. So I have more transaction per second, less idle session because I have really 30 sessions sending queries and transaction to the database. So without this rate limiting, so doing the maximum possible transaction per second there without the connection manager, most of sessions are active. And if I do that with the connection manager, I have more session active because I have more activity on the database. Maybe the total is near 30 because they are all active. But we can see that the latency is just a few milliseconds higher there. And the throughput is a bit lower because there is this overhead, but it can scale a lot better because I can add more connections. And I think, if I'm not wrong, that now that I have a lot of sessions, I can see from my session, from my current session where I didn't run those statements, was PgBench that ran it, I can see from PG prepared statements, the prepared statements that now are shared in shared memory, so visible by all the connection from the pool. And the pool is per database and per user. Of course, different connecting from different users should not share that. Okay, do we have any question in the chat, or maybe we can take that? Any formula do you recommend? So my point with connection pool, and I think it's also your experience, is that it's mostly always too large. Because from the application point of view, you are tempted to increase the connection pool if the database is slow. The problem is that if the database is slow because you already saturate some resources, increasing the pressure cannot be better. So usually, what I prefer is start with a connection pool that is low, where I know it is not saturate the database. So you start low, you run your workload. Of course, if you have some load test, that's perfect. And then you look at the database. If you are not saturating the CPU, if you are not saturating the memory, so you have still available memory, not 100% of CPU, load average on CPU lower than the number of vCPUs. You don't see a lot of I/O latency. Then you know that you can increase it. So increase it. Maybe you started with 100, double it to 200, but then look at those two numbers, latency and throughput. Because what you expect is that if you double the number of connections, then you will double the number of transactions per second without increasing the latency. You know that you are going too high when the latency starts to increase. And then there is also another point in the it depends. So when I answer it depends to this question, first, it depends on what the sessions are doing. There are some queries that are very active on CPU because they read a small set of data from memory. And there are also analytic queries that are doing a lot of I/O. And then you can have more because when they are reading from disk, they are not using CPU. So active sessions, so for example, active sessions 10 times of vCPU can be okay if those sessions are doing some I/O and some work on CPU. If they are all using CPU, then you saturate the CPU. So
that's exactly what I was hoping you would get to, is that It totally depends what queries are being executed, but
Yeah.
if it's more IO bound, then we could be up towards that 10 connection per vCPU limit, or down around 5, let's say, if it were more analytical queries. So that's all that I would have added to that as well.
Another thing that is important also is that an advantage of the connection pool is that it can queue. If the application is trying to open more connection than the maximum in the pool, they will be queued. So the response time will increase. But that's still better than saturating the CPU, because what happens if on Linux, if you have 100 of processes that runs to run on CPU that are in the run queue, but you have only, let's say, 10 CPUs, then the OS will queue them, will schedule them. But the problem is that the OS doesn't know what you are doing. So maybe you have a transaction that started to read something or write or log something, and then at some point the OS will put it out to give the CPU to another one, which is fair. But then the other one will be in CPU just running a few CPU cycles to realize that it's waiting on the lock on the other. And then it has to be back and the other has to progress. The OS doesn't know that there are some sessions waiting for others. If you queue before running your transaction, then you know that at least what you are queuing, it may increase the response time for them, but it will not increase the pressure on the other ones. So always better to queue upfront.
Mm-hmm.
And yeah, there are many reasons for this. It depends about the number of connections. It depends also. Yeah, the best is to test and see what happens. What I wanted to say is that it's better to be lower, because if it's lower, you know that you can increase.
Mm-hmm.
If you saturate the system, then you don't have relevant metrics. For example, on a system where you are saturating the CPU, you may look at the I/O statistics, the network statistics, and think that you have long I/O. Just because doing I/O also has to do something in CPU. So even if your I/O is fast, but you wait 100 milliseconds in the run queue just before seeing the I/O, then it will inflate the I/O metric, where the truth is that you have a problem with CPU. So always better to have it small, because you really control what is happening, and then increase. And then if you increase and you see that you start to saturate, the latency starts to increase, then either you stay with that if it's okay for the performance requirements, or you can start to scale. You know that you saturate the CPU and maybe add new nodes, for example, in Yugabyte.
And it's we've also demonstrated how easy it is to get up and running with some of this performance testing using these tools that we've shown. You really can get pretty relevant insights on what those limits would be if you're providing representative transactions or statements to run with PgBench against these tools. So using the stat statements alone, you seemingly can get a lot of good information.
Yeah, that's right. And because PgBench is not working like an application, because it's just connecting and doing basic thing without a connection pool in the application. But then you can really simulate what the application is doing. And for example, just to see what happens, I can run what you did, reconnecting each time. So something that you will see. Okay, no, that was just this one.
And I should have run my sample printing every 5 seconds like this as well is just.
Oh yes, that the dash
Yeah,
E5.
it's a lot more opaque. Just waiting for the stats to spit out after 20 seconds or however long you run the benchmark. I like seeing how
Yeah.
the
And
trends
also,
look.
you never know if the first seconds are kind of different because of some cache effect. So I know that I start to look at the metrics when they are relevant.
Yeah, so that's a question for you. Like, how do I know? Should I run a benchmark for 20 seconds? Should I run it for 60 seconds? What are some considerations for how long to run one of these benchmarks?
I like to run. For me, the most important is to run it until you have numbers that are homogeneous and that you can
Mhm.
explain.
Mhm.
If I see something that I cannot explain, then I may run it longer. But yeah, of course, it's a
I didn't
balance.
know. I didn't know if any of these metrics would start to, degrade over time if you ran something for longer or something like that. If, but I guess it
It,
sort of
it,
flattens
it
out.
can, in OLTP, you don't expect that it does. But
Mhm.
for example, if I look at what is run there, so this updates a single
Mhm.
account, and insert. I don't think there are a lot of indexes in PgBench. So this is fully scalable,
Mhm.
especially on Yugabyte. By default, this will be hash sharded. So even if the tablet start to grow, it will be split. So this should be fully scalable. Of course, we can run it for hours to be sure, and then
Yeah.
AWS will be happy that you run big benchmark for a long time. But this is scalable. But for example, let's say if I have a query that does a sequential scan on this table where I'm always inserting, then of course at the beginning it will be fast because in Yugabyte, the first insert are just in memory in the mem table of the LSM tree, so that's fast. And then at some point it's flushed and there is compaction, so it's good that your benchmark covers this because this is something that happens with a table that grows.
Mhm.
And at some point, if it's a sequential scan, it can be longer and longer.
Mhm.
So what I would do in that case, I don't run long benchmark also because I'm not patient enough to see that. What I prefer is trying to explain it. If I see something increasing, then I will look at the execution plan with explain, buffers, or dist, where I see what is behind. And then maybe I will look at an execution plan at the beginning and after a while, and just to see if there is a figure that increases. I don't
Mhm.
need to see 1 more minute in the response time to know
Mhm.
that something is different. What I just want to say is that the number of reads or seeks in the LSM trees is increasing or not. And then I know it can be scalable.
Mhm.
Of course, with some experience, when you look at the execution plan, you know what will be scalable or not. You know
Yeah, yeah, yeah.
that your scan will read always the same number of rows or if it will increase.
Mhm.
Um,
And then
yeah.
another question is, so do you see any downsides to using the built-in connection manager, or would it be your expectation that anyone using Yugabyte DB would just default to turning it on, using it?
Good question. The goal of the design is that it is transparent and then everybody can use it and can just benefit from it. It's still in preview. There are still some issues that must be fixed. I can show one, for example, just because it's also nice to show things that may not work as expected, but it's an open issue. Let me just put that here. So here I'm running without rate limiting. And I mentioned that the prepared statements are shared. So that's something I've seen and opened an issue recently. If I deallocate all from there, what we should do is deallocate only the statements that are prepared in this session, but not in the shared one. But in this case, okay, or maybe, so maybe in some case it works. We will see when the issue will be, okay. I wanted to show a bug and doesn't work like a bug. I have no idea why. Because when I see that the statements are shared and visible, I thought, okay, so.
Well, you showed it to me the other day. I know that you're not a liar.
And it's the same version, but yeah, it's still an open issue. So maybe there is some context where it works and where it doesn't work.
Mm-hmm.
But yeah, basically there are still a few issues. So that's the reason why it is in preview. The idea of the preview is that people can test it
Yeah. It's
and
very
give
close.
feedback.
The value proposition is clearly defined. We just need to make sure that it's production ready before it gets out of preview. But usually,
also,
it's
something
close.
that I think we have something about sequences. For example, if I create sequence S, let me deconfig. So here I'm on connection manager. I have no sticky object. If I select next val S, there is no stickiness. Maybe it's curval with 2R. Okay, I don't know exactly, but there are some things with sequences when they are cached in the session where it puts stickiness. And the problem with stickiness is that we don't share it. And of course, we want it to work with sequences, but I don't really remember which corner case we have. So there are still things, but the idea is that in most of the case, it will be able to share like transaction mode, but if your application is creating a temporary table, for example, and forgets to drop it, just expect that it is dropped at the end of the session. Just because you reuse session, then it will be there. So maybe the application can optimize something, but the idea is that it should work the same as without, and just put some stickiness when it cannot share it, and then it will use more connections.
Mm-hmm. And I'm seeing a max connections of 300. So is that
Yeah,
that's if you were connecting directly to YugabyteDB, or is that something having to do with the connection manager?
no, so this is directly to YugabyteDB, and then it acts also as a limit for the connection pool. We can see the parameters. I have a line that I copy paste that just curls on the variables visible in the HTTP endpoint of each tablet server. Of course,
Because I was a little bit confused, or I was looking into the connection limits between Postgres and PgBouncer. So you can establish more connections to PgBouncer than PgBouncer connections to Postgres. So what happens with those additional connections? They're just queuing whatever is being run against the database, I guess, in that intermediary. Yeah. I didn't know if Yugabyte would have the same thing where you could have more logical connections than physical connections or something like that.
There are multiple parameters, or maybe the best is to look at the documentation on Connection Manager. Yeah, there are multiple settings, one to enable it, but there are also some settings about the connection.
Max client connections, it says 10,000.
So that's the logical connections.
Yep, that was my exact question then, because that's an important distinction for people who are learning how these database connection proxies work and the difference between the logical and physical connections. This is
I also
huge
I
difference.
don't remember if I opened a doc issue or just mentioning to the colleagues in the doc team. Yeah, it would be nice to see logical there.
Yeah.
The problem with this kind of software that uses multiple existing components like Odyssey, you have some parameters coming from Odyssey, you have some parameters coming from Postgres, and then the question is, do you change all names to build something consistent,
I know.
or do you reuse the names because it's always easier, because the goal is also to merge with new versions of Postgres, new versions of Odyssey. So yeah, it's difficult to be really consistent with all those components, but also still be consistent with each component. So maybe the documentation can be improved there.
Well,
This is the logical.
I appreciate the name of the parameter, the connection manager max connection. They made it very clear. So this is really cool. I look forward to turning this on and checking it out in my future applications.
And there are statistics also on port 13. I think it's 13,000 or something like that. There are statistics, and we can see that also on the managed service to see the number of logical and physical connections. So there are statistics gathered, but all that can also improve from the feedback. That's also the good thing, being open source, having people using it and opening issues and giving feedback.
Very cool.
Okay. Yeah, it's time to close up. Let's see if there is any more question. Thank you for questions, especially Naganda with the questions on connection pooling. It's never easy to size a connection pool.
No.
Always better if you can reproduce some kind of workload, even if it's not exactly the same thing that is running in production. Always good to be able to run some kind of workloads.
You can always reach out to us too. In community Slack, you can always reach out, and someone will let you know any pointers that they might have based on your specific workload. If you're willing to share or would like to engage with the community, I always recommend people join the Slack channel.
Yeah, it's really important to have feedback. We have feedback from very big customers, those who pay for support and give feedback about how they use it. But it's also important to have feedback about small deployments who may just run open source and helps to improve the product. Okay, perfect. Thank you very much. And let's say in the future open hours and all questions on Slack or whatever Git issues.
Yeah,
and,
I guess we'll see everyone next time. Frank and I will both be delivering workshops at the Distributed SQL Summit. That's something we didn't mention at the onset of this, but Frank will be talking about database indexes, I believe, and I will be giving a workshop on developing AI applications backed by Postgres using PgVector, and how to incorporate that in YugabyteDB as well. So look forward
and
to
that will be free and online, the Distributed SQL Summit.
Yeah, cool. Well, thanks a lot.
Thank you very much. Bye.
Bye.